So we're looking at question 2 in our first lab, and we are asked to follow Euclid's algorithm for finding the greatest common divisor of two positive integers. So let's set this up with the values that we were asked to use first. So we have 20 and 32, and this is the greatest common divisor. And we know that without doing this formula here, this process, that we should have a solution of 4. Now, to follow this, the first step in this algorithm that's written out states that we call the larger value j and the smaller value I. You'll see that I have actually changed the position of each one of these variables for j and I because, well, alphabetically, I comes before j, and I just want to keep things in a format that makes the most sense. You can use any variable you want. You could have used a and b, x and y. Doesn't really matter as long as the consistency in the process stays the same. So I have my smaller value set to I. I have my larger value set to j. To see how this works, as this process would probably make sense in a computer program where the computer understands what each one of these steps is suggesting the operation complete. But from a personal standpoint, this really is confusing the first few times through. So let's just look at the math outside of these steps to see how we would solve this, still using Euclid's algorithm. So to set that up, we will say that j is equal to I multiplied by q plus r. Let's define those variables. We already know what I and j will represent. We know that those are going to be the values of 32, I will represent 20, and we are saying that q is equal to I and j. So essentially we're going to divide j by I, or you could set this up as you could set this up as j divided by I. So that's what it represents. It represents how many times, so how many times will I go into the variable j. The variable r is going to be the remainder if r does not equal 0. And we'll see how this works, but this is essentially the rules of those variables for this process. I'll put those up here out of the way. And I'll make a little more room. So to begin with, we don't know what Q is, and we don't know what our remainder is. So let's solve for that. So off to the side, let's just begin doing our division. So we're going to say 32 divided by 20. 20 will go into 32 just one time. And our remainder is 12. And Q really isn't that important. You'll find that really Q is going to end up being a placeholder. We do not actually use that as part of the formula. So we're really concerned with just the remainder, just that value 12. So let's go ahead and enter that. So we have 32 is equal to 20 multiplied by the one time it went into it, plus our remainder of 12. So next, we're going to move I into the J position, and we are going to move our remainder into the I position. So to show this another way, let's move this back down. So we are moving I into the position J, and we are moving R, the remainder, to the position I. So let's see that in motion. So we're going to have 20 is going to take the place of 32. So we now have 20 is equal to, and where 20 used to be, where it used to be right here for I, we now have the value 12. So we're moving 12 to the position that 20 used to have. We are going to multiply by Q. We're going to reset our variables, plus R, the remainder. Then again, we're going to divide. So it's going to be 20 divided by 12. 12 goes into 20 just one time. And our remainder is going to be 8. So now we can put those into our formula, and we have 20 is equal to 12 times 1 plus our remainder is 8. We have to continue until our remainder is equal to 0. That's when we will stop, and we will have the greatest common divisor of these two numbers. So we're going to repeat this process. So we're going to move 12 to where 20 is, and we're going to move 8 to where 12 is. We'll reset our variables Q and R. And as you can see, we have not used the variable Q in any way mathematically. So now that we have our equation set up, we can do our basic division again. And we are going to divide 12 by 8. 8 goes into 12, again, just one time. We have a remainder of 4. We'll put that into the equation where we have 12 is equal to, and I will show that. I'll continue showing this. So we're going to move 8 to where 12 is, and we are going to move the remainder to where 8 is. So let's do that. 12 is equal to 8 times 1 plus 4, and shouldn't have shown that here. Sorry about that. We will move 8 over, and we are moving the remainder 4 over. So now I would just like to point out where the variables are in this formula. We can see that we have a remainder of 4. We know that we're getting close to our remainder equaling 0. So what we're going to do when we set this up is we're going to have 8 is equal to 4 times, and reset our variables, q plus r. And looking back up here at the top, we said that in this position is j, in this position is I. So let's mark those. So we have j is in this position, I is in this position. And let's go ahead and do our division as we have been. So we'll repeat the process. How many times does 4 go into 8? Well, it goes into 8 perfectly 2 times. And we finally have our 0 remainder. Now that r is equal to 0, we must stop. And we will display, and in this case, because I have reversed these variables, it says print out the answer, which is the value I. And if we go back down to our formula, we can see that I, in that position I, that value is 4. So when we print this out, we are going to say that I is equal to 4. That is the solution for the greatest common divisor, and our program should stop. So now that you have seen how this works, or is effectively working, the process of 1, 2, 3, 4, and 5 all the way through stop, but you're repeating step 2 and step 3 until you reach the remainder of 0 for r, this makes a lot more sense. But our next issue, the next problem that we have, is what happens when we have 2 positive integers, but it is not defined any more than that. So we have 2 positive integers, and it states that we are using 0 and pretty much any other number. I'm going to use 32 again. Well, what happens when we have that and we set this up is that our smaller value I and greater value j will be established within Euclid's formula, such that 32 is equal to 0 multiplied by q plus the remainder r. When we do our division, we are simply dividing 32 divided by 0. Well, this may not tell you what's going on, but if we write it another way as a fraction, we're trying to divide by 0, and 0 is in the denominator. We can't do that. So effectively setting this up for any positive 2 integers without specifying that it must be an integer greater than 0 for the integer means we could possibly run into division by 0. We cannot mathematically find division by 0. So we need to state in the first step, as long as the integers are greater than 0. Further, we could also enter an argument or error that would print if somebody accidentally enters a 0 as one of the integers, and just simply state that this would create division by 0, enter a number greater than 0, something to that effect. I hope that helps. Thanks for watching.